Welcome to Cookie's Maths and Science Hub. Today we'll be looking at graphs of motion and how to read them. First up is position time graphs. Now these graphs can be used with either distance or displacement. We're going to use displacement for these examples. Recall that displacement represents the change in position from the initial to final point. So this is effectively our position from our initial point to our final point. On the graph, this is shown as the position of an object at a particular time. So on our x-axis, we have time, and on our y-axis, we have position. So time is often given in seconds and position in meters, but just be careful when checking your units that you correspond them to the graph appropriately. The gradient of these lines represents velocity. It can be positive in the forward direction or negative in the opposite direction. So on these examples here, we have constant velocity going positive up and then negative down. We can also have changing velocity, which is when the line is a curve on our graph. Perhaps the most common type of graph you'll encounter in your physics studies is the velocity time graph. Recall that velocity represents the rate of change of position with respect to time. On a velocity graph, we have our velocity on the y-axis, our units for velocity are meters per second, and our time, in this case in seconds, but can change depending on the units used for the question. Now, the velocity or speed of an object at a particular time can be determined using the axis. So if we wanted to go to a particular time, we just look at its time coordinate on the x-axis and we match it with its velocity coordinate on the y-axis. Now, the reason we use velocity time graphs so much is because it can give us two key bits of information. From a velocity time graph, we can find both the displacement and the acceleration at certain points in time. The acceleration of an object is equal to the gradient of the line at a particular time. So here on our graph, you can see we have a changing velocity, which is where it is sloped, and that means it is decelerating as it's going down. Our velocity is getting smaller or accelerating in the opposite direction. Then on the end of the graph, you can see once again, we have a slope of changing velocity, which means we're accelerating in the positive direction. It's important to notice that it has both a positive and a negative aspect, as when it's below that timeline or the x-axis, we're going to be going in the opposite direction. Now you can also have constant velocity, which is where your line is just going to be straight, meaning there is no acceleration as the gradient equals 0. We can also get the displacement or distance that the object travels from the area beneath the graph. That is the area between the line and the x-axis. In this case, our object travels both forward and backwards, given if that is our direction. Therefore, we would have to add the top bit and subtract the bottom section to get our overall displacement from our initial position. Finally, we have acceleration time graphs. Recall that acceleration represents the rate of change of velocity with respect to time. We don't use these ones too often, but they are still important that you recognize how they look and what can be deciphered from the information. This graph allows us to see how the acceleration is either constant or changing throughout the motion of an object. On the right-hand side here, we have an example. You'll see our y-axis is our acceleration, much like the others were distance, displacement, position, or velocity. And our x-axis is once again our time. Remembering the units for acceleration are meters per second squared. The area beneath our line, that is between our line and the x-axis, gives us our velocity in these examples. This is the most helpful part of these graphs. Thanks for watching. Hopefully now you have a basic understanding of the three types of graphs of motion. Be sure to leave a like and comment for future videos you'd like to see us explore. Be sure to subscribe to the channel for all your future maths and science needs. Hope to see you again soon.